Hi, I'm Jeremy Simon with 3D Universe, and welcome to another episode of 3D Universe Untethered. In this series, we get to hear from people across varying industries about the great things they're doing with digital fabrication. As always, you can visit 3duniverseuntethered.com to see all of our episodes and access recordings of our previous episodes. You can also get 3D Universe Untethered as a podcast through all the major podcast platforms. In today's episode, I'm going to be speaking with Morley Kert, a designer, maker, and content creator. Welcome, Morley.
Hey, how's it going?
It's going great. So, Morley, on your About page on your website, you say this: ever since I was a young kid, I've loved to tinker, build, modify, take things apart and maybe not put them back together again, invent, design, engineer, create art, make videos, and learn new skills. I thrive on the challenge of building projects with limited tools and space. I believe that not having something can be a wonderful source of creativity and inspiration. So that's a great intro, and I think it gives us a great place to start. So tell us a little bit more about that, of how you got into this whole process of making, playing with things, tinkering, improving on things. Just when did this all start for you?
Yeah, so it's hard to point to any singular event, but like I said in that About page, I think as a kid, I was always very curious. I was always asking lots of questions about how things worked and how buildings stand up and all sorts of things. And I'm very lucky in that my parents answered all my questions and they were very patient with me. My grandfather growing up was an engineer, and I spent a lot of time with him and my cousin in his basement, which was like this amazing, fantastical place for a 9-year-old because he had all this metalworking equipment. He had a Bridgeport and a metal lathe and all these electronics and shortwave radios that we would play around with. So I don't know what exactly sort of ticked it off, because I feel like or not, that's a bad way of putting it, but sparked that interest, because I think I had a very well-rounded childhood. I just liked trying a lot of different things, but it was a definite sort of constant theme throughout my childhood that it maybe took me until university to realize how important making stuff was to me. I was into architecture a lot when I was in middle school and high school, and that was probably the most consistent career goal I had as a child. But then when I was in high school and I got more into math and science and kind of excelled in those because it always feels good to be good at things, I decided that I wanted to study civil engineering. It felt like this nice marriage of architecture, but also the more scientific approach to it. Build big things, essentially, I thought would be really cool. So I grew up in New Hampshire, and then I went to Montreal. I studied civil engineering at McGill University. And pretty soon, I kind of missed making things with my hands. And I started getting into the YouTube maker videos. So some people like Matthias Wendell, Jimmy DiResta, I Like to Make Stuff, Ben Ueda, those were Adam Savage. I always loved Mythbusters growing up. I was watching those, and I kind of felt this opportunity because I could start my own tool set. Growing up, my dad was a homeowner. He wasn't a woodworker, but he had all the homeowner's tools, and we had a workbench in the basement. It wasn't very organized, so it wasn't the most inviting place to go make stuff. And maybe that was part of the reason why I didn't complete many projects as a kid, or maybe it was just being a kid. But then when I got to university, I was like, wow, I can actually do these things myself now. And so I started collecting used tools. I had that first big project, which was building a full-size loft bed in my apartment in Montreal, as my 3 roommates tolerated all the banging and crashing around. So shout out to them for being very tolerating. And I had made some YouTube videos in the past because I'm 25. When I was a teenager, young teen, YouTube was getting really, really popular. So I wanted to do that as a kid. And in university, as I started watching these making videos, I was like, well, I want to make videos about making stuff too. And I started doing that. And pretty soon I realized that I absolutely loved making stuff and making videos about making stuff, to the point where that was kind of my main extracurricular in university. As university went on, it kind of slowly became more and more consuming in a good way. I just really enjoyed doing it. And I picked up leatherworking because when I was working in an internship one summer, I didn't have access to all of my woodworking tools that I had started to collect. But I still had this outlet. I wanted to make stuff. And so I picked up leatherworking because it seemed like this beautiful, relaxing craft, which it is. And that became a really fun thing for me. And then after graduating, I got an engineering job. I really didn't like it. I felt like I was in totally the wrong place. So I ended up leaving and eventually kind of found my way to where I am now, where I'm really focusing full time on content creation and making a career out of that. And very grateful that things are sort of working out. And in that whole journey, after leaving the engineering job, right around the time COVID hit, I started thinking, wow, 3D printers are pretty cool. I just got this nice stimulus check. Maybe I should spend it on a Prusa i3 Mark III's, because all my maker friends say that like that's a great 3D printer to get if you don't want to tinker and you just want to like start making things, which I was interested in. And I know like 3D printing has a huge history with the open source nature of it and people building their own, and that stuff's cool. And I like tinkering to a certain point, but I really just wanted to like start printing and not have to troubleshoot the printing process. You know, there is troubleshooting, like it's not a perfect printer, but sure. I've been very happy with it so far. And I didn't really have a specific idea when I first got it, because at that point and before and after, like I was making a lot of things for videos. So I didn't know exactly how I was going to integrate these into my videos, but pretty soon I started integrating a lot into my leatherworking and making custom stamps and things, which I wasn't the first person to do that, but a lot of people really enjoyed seeing that because it's this huge opportunity, right? Because everyone wants a custom leather good. And if you can make a stamp with like 5 cents worth of filament, and you have a robot do all the work, then it's amazing. Mm-hmm. So yeah, and it kind of just kept snowballing from there. Found more and more uses for the printer and other sorts of fabrication methods.
Yeah, it's funny how that happens, isn't it?
Yeah.
Once you get the tool, you find all kinds of things you can do with it. Now, it's a great background. Thanks for sharing that. And one of the things that caught my attention is, you talked about how you were exposed to a lot of these sort of tools, the workshop that your dad had as you were growing up. You didn't maybe really get into it in depth until later years as you started to get older, but do you think that maybe being exposed to that when you were younger and being around it maybe ended up having an influence on that and at least brought it around into your thinking a little bit more than it might have otherwise? Do you think there was some benefit of being around that?
Definitely. I think it was always this part of my life that like I was very interested in, but I also had a lot of other interests. So I think like many makers, having a wide range of interests is like a blessing and a curse. And especially as a kid, when you don't have much motivation, it's hard to like, I was into school and sports and then like other things here and there, but those are kind of like the main focuses of me on my childhood. It wasn't imposed on me. It was just the things that I kind of naturally fell into. But yeah, being exposed to those things was super important. Like my grandpa to this day is a huge inspiration, and just watching him fix a weed whacker, like me and my dad brought over a weed whacker that was broken, and seeing him like very methodically go through the process of troubleshooting it and eliminating possible problems one by one, like sticks in my head to this day.
Oh yeah.
So yeah, seeing that in person, it was massive.
That's terrific. That's terrific. And I got to say, congratulations on really sort of zeroing in on what you love to do and keeping that your focus and building something around that. Not enough people do that. And it's great to see somebody at still a fairly young age who has gotten onto the right track. I love to see people doing what they love and figuring out ways to make a living from that.
Yeah, I mean, it's not without its trials and tribulations. Like the time between leaving that engineering job and now was a lot of twists and turns. I worked for a scenery shop for a brief time. I thought I wanted to be a teacher, but I'm excited where I am now. There's probably more bumps in the road along the way, but I'm happy to be doing what I'm doing.
So you've been doing a lot of making for a long time, and as you mentioned, it was a couple of years back then that you started to get into the 3D printing side of it. How did that change the process for you? How did your experience of making things, or even your thinking about what was possible, start to change when you had that tool available?
It changed a lot, and I think a big reason for that is at the time and now I was working out of a small city apartment. So I wasn't able to make a lot of the things that my friends were able to make in their wood shops. So even just making a straight cut in wood was very challenging because I didn't have a table saw. I would have to find a parking spot outside somewhere, set up sawhorses, and set up a fence in my, it was all very, very janky. So all of a sudden having a precise way of making things was something that I had never had before. So I think that was one of the things that was really exciting right off the bat, was having precision. And it's obvious looking back, but like I started making leather templates out of like 3D printed material, which seems like a kind of inefficient use of it. Because if you have a laser cutter, for example, right, it's like 4 cuts to make a square and it's done in 30 seconds. But with a 3D printer, you got to like 10 layers of filament. It might take an hour. But for me, like that was a great way to use it, because I could set the 3D printer going, I could do something else for an hour, and then I had a repeatable template that I could use to make a wallet or whatever else. So just having access to precision making was really, really exciting. And so that was one part. But then the other thing was, all of a sudden I could like directly make 3D models that I created on my own. So in studying engineering, I learned about 3D modeling, and we were just doing it in AutoCAD, which is, and a little bit of SketchUp. It's a dumb software, I will say, in that it doesn't know that a box is a box. It doesn't know that a sphere is a sphere. If you delete an edge, the whole model might break. You know, it's very basic. And when I got my Prusa, I was like, I want to be using Fusion 360 by the time it arrived. So I took like a 30-day Fusion 360 course, and all of a sudden I could like make my ideas a reality, you know, on a relatively small scale. But yeah, it was super exciting to like be able to model something and then make it real.
It is. And that's really one of the things that I love most about your videos. And we're going to get into talking about some of those here in a minute. But the fact that you know, some of those things that you've made, you probably could have gone to one of these sites like Thingiverse or something. You probably could have found something that would have done the job. But I love that you go to CAD software and you think about, how do I want this to be? What's going to work best? And you create it from the ground up. And I just love getting people to think in that direction of making it for themselves and making it so that it's exactly what they want. So I love how you're not just showing what you can do with 3D printing, but the process leading up to that of how you can bring your ideas to life and get them ready for 3D printing. So let's talk about a few of these. There's so much great content on your YouTube channel. I definitely encourage people to go and check it out. We're going to include links to all your sites in the description down below this video, but I do want to talk about a few of these. And as I was going through your YouTube channel, some of these kind of drew my attention especially, and I broke them down into a couple of different categories. And if you don't mind, I'd like to just talk through a few of these and hear a little bit more about, you know, why you created it, what you went through, what the process was like for each one. So the first category that I focused on was, you've got a number of videos that deal with either fixing or improving upon things using 3D printing, especially things that might be either very expensive to fix with traditional parts or buying parts, or, you know, impossible parts might not be available at all. So, for example, there was one where you talked about fixing a vintage time clock. And right in the caption of the video, it says they wanted $100, 3D printed it for 9 cents. So that is, you know, that caught my attention, because that's the sort of thing that you hear a lot with 3D printing, of something being such a fraction of the cost of what it might otherwise be. So tell me about that one. Why was that part so expensive? Is it just because this was such an old item that getting parts was costly?
Yeah. So I found the punch clock on Facebook Marketplace, and I wanted to get one because I saw this art exhibit where an artist had used one of these old punch clocks to track all of their time that they spent working on their own projects. And I just thought they were like a really cool gizmo that probably had a lot of interesting stuff going on inside. So I was like, I'm just going to buy one. I can probably make a cool video out of it or something. I don't even know if I had a plan at the time. But when I started using it, I realized that the ink ribbon wasn't advancing, because you would put the card in once and you get a nice crisp stamp, and every time you put it in after that, it would get fainter and fainter and fainter. So I was like, well, this could make a very interesting video about fixing it. Well, actually, before I even thought that, I was like, let me kind of try to see what's going on in here. So I opened it up, and it didn't take long to sort of figure out what was going on. Like, there was this cartridge that was missing a little gear that advanced the mechanism, basically like the ink ribbon. And before I even started the video, I just emailed the manufacturer being like, hey, I think I know what's wrong with this. And I was trying to get their help in fixing it myself. Out the gate, I didn't want to just buy something from them. I was like, can you maybe help me do this? And my thinking was that it's a very old machine. They're probably not selling a new one. Maybe they'll help me out out of the goodness of their hearts. And they, it was a relatively complicated ask. And they offered a replacement part for around $95. And I kind of sort of came back with like, well, thank you. I really appreciate that you're supporting it. But I think it's really just one little thing that I need. Long story short, they couldn't help me. And so I was like, well, I'm going to fix this myself. I think I can figure it out. And it was a really interesting process of figuring out that it was a ratchet gear that was missing. I actually saw it in a shadow on the metal. Like you can see the shadow that was caused by the absence of it in the dust. And then I found a single video on YouTube where someone had just restored one of these, and you can see in like 2 frames that there was this nylon gear where this used to be. And I was like, I can 100% design this and 3D print it myself. I mean, it's very simple. It's really just a gear. The teeth count doesn't matter because it's advanced by a pawl. So as long as it's like approximately the right amount, it should work okay. So it took 2 iterations of prototyping, and I had a working punch clock. So it was really fun. And I mean, it's my top performing video. I think That's 1.5 million views now. So people really enjoy the saving money aspect of it because that's why people click, They wanted $100. I 3D printed it for 9 cents. But I think I can tell from the analytics, a lot of people subscribe to my channel from that. They like seeing the whole process of like using 3D printing to fix something that may otherwise be impossible or you just have to buy it.
Yeah, and not only the process of doing it, but in this case, what's interesting to me is you had to build something that was completely missing. You didn't have the benefit of taking the original part and getting reference photos and things like that. You had to kind of figure out what needs to go in there, and that's very cool that you were able to investigate and find little bits enough for you to figure out what it needed to fit like, and then build it in CAD. So that was a great project.
Thank you. Yeah, it was fun and very satisfying, getting a working clicky ratchet. Like I was just playing with it for probably 10 minutes before I reinstalled it.
Oh yeah. Yeah. And that's what I hope people watching and listening to this will get, if nothing else. If you've got a 3D printer and if all you've done so far is sort of downloaded things that other people have designed and printed them off, and getting to know the printer, that's all well and good. But there's nothing like coming up with something that you need to fix or something that you want that isn't available, and designing it for yourself and printing it out and going through the process of iterating if needed and then getting that final working part. It's really rewarding, and I love how that's incorporated in so many of your projects.
Thank you.
All right, so let's look at another project. It's in the same category of fixing things that might be either expensive or difficult to find parts for. You fixed a glove box in one of your cars. It was missing some kind of a latch to sort of prevent it from opening too far. Tell me a little bit about that project and why you took the approach that you did there.
So that was part of a challenge I made for myself to make a video every day for 5 days. Which was so much fun, and I would love to do again. It's just, it takes over your life. So finding a 5-day span where I can do that is a little tricky.
Oh, yeah.
So I had some ideas before I started that challenge, but I ended up sort of coming up with each video the night before. And that's what I really like doing in a lot of projects. Like when I'm excited about something, I just want to do it immediately. And I think that contributes to my videos, I hope, being the quality that they are, is like that excitement comes through. And in this case, that glove box was broken for months, and I was kind of just living with it. And you can see it in the video, like every time I go back to test the next part, I had mistakenly put everything back inside, opened it, and then everything falls out because I just gotten so used to living with this problem. And the problem, I don't know if I described it, was that there are these clips that hold a glove box open. So if you open a latch and it kind of falls open, and these clips hold it in an open position. But one of those or both of those clips had broken. So my glove box would fall entirely open and everything would fall out. And it's kind of funny because a lot of my videos are about like solving frustrations, but I'm also a person who will ignore frustrations and kind of just live with them. So to find those, sometimes I need to really think about like what is annoying me in my life and what would benefit from being solved. And so I realized that was like, great, that'll be an awesome video. You know, it's similar, like you said, similar to the punch clock in that the thing was missing. So I need to kind of reverse engineer how it works. So it was fun because everything builds on everything else. So the mechanism for that, which was like these little clips that go into the glove box itself, and then there's a sort of a little hook that hooks onto the interior of the dash. Those little clips were based on another project that I had done a couple years before, which was at our old apartment, the fridge was missing that little railing that holds things on the door. So I made a new one with like a little 3D printed connector and a dowel. And I used the exact same little clip mechanism to hold it in. So since I kind of knew that worked, I was pretty confident that it would work in this case. And I mean, to talk about satisfying clicky movements, like when that clicks into place and all four of those little teeth just engage at the same time, it's great. So it's funny because that was part of this 5-day challenge. Like I had made the choice to complete it within a day. So without knowing that context and watching that video, you might be like, why is he rushing around so much? Like this, at the end, I'm like, I'm running out of daylight. I got to get this finished. But I don't think that sort of sacrificed the quality of the project because it's lasted throughout the hot Toronto summer. It's a relatively simple fix. And that's one of the things I enjoy about these sorts of projects is that with a lot of practice in Fusion 360, they don't take very long to actually make. People always talk about 3D prints take forever, but if you print small parts like that, like each of those took around 20 minutes to print.
Yeah, and when you have something that might be bigger or might take longer, I don't know if you're like me, most of those happen overnight. So you start it going, you go to bed, and your part's ready in the morning. So even then, it's not really an issue. But you also touched on something else that I think is worth focusing on a bit more. You talked about eliminating frustrations, and that's an aspect of 3D printing that I don't think gets enough credit. People don't realize how these maybe little minor frustrations can sort of build up, and it can sort of affect your day. And it's easy to underestimate that. And like you said, it might not be a big enough frustration that you're going to go out and buy a solution for it. But when you can make a fun project out of it and design something yourself and 3D print it, not only do you get that rewarding experience of being able to solve this for yourself, but you then get the ongoing benefit of having eliminated that frustration, which I don't really hear enough people talking about. It's a cool aspect.
Especially spending so much time at home, as a lot of us have for the last few years. I've also been like always really interested in ergonomics. Like my mom is an interior designer. She's always like in setting up a room, she always is very mindful of like, how will this room be used? How are people going to be moving through this room? You don't want to put a chair. I mean, it sounds obvious, but something as simple as you don't want to put a chair facing a wall because who wants to stare out in a wall rather than looking out into the room? And then because I live in a small space, it makes every little decision like that just amplified because there's not much room for spreading out. So it's fun. It's nice to be able to like make those small changes that make your life a little bit better.
It is. So you've got a bunch of great videos that kind of fall into this category of replacing a part that would be too expensive or too hard to find. And that's really a wonderful aspect of 3D printing and I think some of the most fun projects that you can have as well. But then there's also this idea of taking something and improving on the design, not necessarily fixing it. Maybe there's nothing broken, but you just want to make it better or get something added that the original designers maybe didn't think of. And you have a video about the Blue Yeti microphone that caught my attention. I do a lot of audio stuff on the side as volunteer work, and a lot of the people in the music community that I work with love these Blue Yeti microphones. And so I was really interested to see what you did there. So tell us about what you found lacking in that design and a little bit about how you approached that.
Yeah, so to really try to paint a word picture, the Blue Yeti microphone, it has a gain knob on the back. And I guess for a little bit of context, like I have a podcast that I do with some friends. And before I got this microphone, I used a Blue Snowball, which is a very simple microphone. It has no knobs on it. You just plug it in, you can adjust settings in your computer, but you can't adjust anything on the microphone. So when I got this one, it took a bit of getting used to. And one of the features that I love now is that it has a live monitor. So you plug your headphones into the microphone and you hear your own voice, which is very unsettling at first, but pretty quickly it becomes really helpful because you notice how loud you're speaking.
Exactly.
And so this gain knob, gain is a technical term and I'm probably going to butcher the technical definition, but essentially it changes how sensitive the microphone is, how loudly your voice is coming to the microphone. So before our podcast recordings, when we are getting all set up to go, sometimes everyone's like, Morley, you're a little loud or you're a little quiet. And I'll be like, okay, let me just adjust the gain. And this gain knob is on the back of the microphone. So I'll reach around to the back. I'm doing a little bit of mental gymnastics because I'm thinking, okay, if this is on the back, as a consumer, am I supposed to think about that I'm turning it like righty-tighty to go up? Exactly. Am I supposed to be thinking about it at the front? So I have no idea which way actually turns it up or down. And that might not sound like a big deal because you could think, well, just turn a little bit and you'll notice a change. But because you have this live feedback in your ears and you're hearing your own voice through your head, it's actually very difficult to tell if it's getting louder or quieter before you make a huge change. So you make a really big change and then you're like, oh, obviously that way makes it louder or quieter. And then got to return back to where we started to adjust from that point. But this knob is one of those like futuristic, ultra smooth knobs that has no physical stops at points.
And there's no visual markers. Yeah.
No visual markers because it's on the back of the microphone as well.
Yeah.
And so it's not very user friendly. Great microphone. That knob is not very well thought out in my opinion. So I was like, I can probably come up with a solution for that. So I'd recently started experimenting with TPU and was really excited by it. So I essentially, and you wouldn't have to do this with TPU, but in my case, I designed basically a cover to go on top of the knob, and it has an indicator on it that I could feel. So, it's a 3D kind of line that's coming up. And because it's TPU, it's a really tight fit. I could print it exactly the same size as the knob. Didn't have to worry about interference or clearance fits or anything like that. It just kind of snugs into place. And then I made a little, almost like a dial that goes around it with little slots for a pin to go into. So I can set that pin at like, this is the sweet spot where I want to keep it 90% of the time. And I also added a little like low to high symbol that I can sort of feel with my fingers. And the result of it was essentially a blind accessible knob on this, which I didn't really think about at the time, but I started getting some comments about people saying like, this really points out the fact that a lot of design is not very mindful of people who can't see.
That's right.
And I was like, that's a great point. Obviously you can't see something that's on the back, but for any other dials in the world, a blind person could probably not use the more futuristic ones.
Yeah.
Right. Yeah, it was, it's nice now that I know exactly where that knob is supposed to go. And it was just a very interesting exercise in like, how do you make something more user-friendly? How do you take a product that's already really good, but just has that like one thing that drives you crazy and make it a little better?
Absolutely. And then being such a popular product, you can now make that design available to others and they can improve theirs too, right?
Yeah, definitely.
So there's a lot of great opportunity with that now, but you mentioned TPU, and I agree. It's such an interesting material, and there's so many unique sorts of applications for that. There's another of your videos that focuses on using TPU, where you talk about making non-slip pads for furniture. But that one really caught my attention because of the approach you took on the modeling side of it. You could have done this as a very basic, just, blocky kind of basic model, but you took a bit of a different approach. So tell us how you did this and why you took the approach you did there.
So when I got TPU, I was kind of surprised about the texture when I got it for the first time. I think I was expecting something that felt very rubbery, but to me it felt a little more just like flexible plastic. It wasn't really sticky like I expected it to. And so I was asking my friends who had used it, like, does it, when you actually print something, does it feel very like non-slip in that way? And he said, well, not really. It's just very flexible. So I was doing a little research and I learned that some shoe treads are actually made out of TPU. And I thought, well, that's interesting. If I take a shoe and I feel the bottom of it, it doesn't necessarily feel non-slip. But then once you put some pressure on it and the friction builds up, it does get non-slip. And on top of that, you have a tread pattern, which adds to that. And so I thought, well, if I just emulate that in a non-slip pad, I'm sure I can get the same effect. So I essentially modeled in Fusion a little tread pattern just on a rectangle with some screw holes because I mean, how many times have you had non-slip feet on your furniture that it's attached
Falls
with
off.
that like double-sided tape and it falls
Yep.
off the moment a bit of dust gets in it. So I
Right.
was like, I don't want to ever worry that this is coming off. I'm just going to screw it into place.
Nice.
And it worked well.
And the other thing that you did in there, which you do in most, if not all of your videos, I've noticed, is that when you're designing parametrically, where you're actually defining parameters for different aspects of the model. Height equals so many millimeters and width equals so many. And that way you can go back and adjust those things later, which is great to see. Not enough people learn that approach. And I think it's especially powerful with 3D printing. Because as you know better than and most of us, your first attempt doesn't always work, and so you have to go back and this one needs to be a little bit shorter, or this needs to be a little thicker, and then you can print another one. So I like to see you taking that parametric design approach because it makes that so much easier.
Yeah, it's I mean, I think a big part of it is because I originally learned 3D modeling in AutoCAD and SketchUp. The fact that those didn't have those capabilities and then learning that those things existed was super exciting. I'm like, I'm never going back to the software that if you delete a line, the whole shape breaks.
It all falls apart.
I mean, and that's not exactly parametric, but the parametric part's being able to change things and define your model in such a way that, so in the non-slip pads, for example, the first one I made, the tread pattern was so fine that the TPU couldn't really print it accurately because it just got a little gooey when it was trying to print that small.
Yeah.
And because I defined that tread pattern parametrically, like, you know, make the rectangular pattern a number that is a parameter rather than just a number. And then you just go into your parameters and you change it and the whole pattern updates. It made it just very easy to iterate. And I mean, on that note, I think I used to try to like get it right the first time, but especially in printing small parts. Now what I do when I design is I basically try to get to a minimum viable product as quickly as possible, because 3D printing with an FDM printer, it's not the most accurate thing in the world. Like that nozzle has some dimension to it. So there's always going to be little inconsistencies, especially when you're trying to get some sort of fit. So I'm like, yeah, I have these measurements and I can measure it with my 1/1000th of an inch calipers. But at the end of the day, I need to get that first prototype to see what I need to change, because odds are that first one is not going to work.
So you actually print that first part and then take measurements based on what needs to be a little bit thicker, a little bit longer, et cetera, and adjust from there. Very smart. Very smart. Okay, so another one I'd like to learn a bit more about was a video where you show a project of building an articulating camera arm. And there were a couple of things that I found interesting about this. Number one was I've never seen a design that was so robust that it could actually be used for a heavier piece of gear like a DSLR. You know, most of the ones you see are for little smartphones and that sort of thing. And I was then further interested to learn that that design originally came from someone else who, and I don't remember the name, you can remind us of that. But he designed it for traditional fabrication methods using plywood. And the idea of taking a design that was made for woodworking and translating it into something that can be 3D printed was really interesting to me. So talk to us about that and what that process was like.
Yeah, so the original design is by a guy named Ben Paik. He runs a channel called Wobie Design. So he calls it the Wobie camera jig. And you're right, it's a very robust camera arm designed to be made out of plywood. And him being a fellow maker, I've seen it a lot. And I've always kind of like wanted to make one because it's a super flexible item, especially in a small space. You all of a sudden don't have the space of a tripod because this design just clamps to a table. You can get really nice overhead shots with it. So it was something I wanted. And I just had a thought one day of, it's a popular enough design that a lot of people have made it and made their own videos and Instagram posts about it. But I was like, has anyone 3D printed one? And I couldn't find one. I think some people have, but at least in my own search, I couldn't find one. So I just saw it as kind of a fun challenge, especially going back to like when I first got the 3D printer and I wasn't able to, I wouldn't have been able to make this out of plywood when I first got that printer just because I didn't have the setup to do it. Now maybe I could a little bit more, but I was like, I want to see if I can 3D print this. I think this could be really, really interesting. So I designed it to be printed out of PETG. Usually whenever I'm going for strength, I'll go for PETG. Yep. And because he had the plans available in vectors, it was pretty easy to just import into Fusion. But there was a bunch of small changes that I made that just made it like easier to 3D print. So one was You know, the original design, there's countersinks that you're supposed to drill out. Well, I'm going to put those countersinks directly into Fusion so that they're printed directly. The original design calls for threaded inserts. And I thought, well, could I just 3D print some threads to screw the bolts into directly? And I learned a very interesting lesson there about the strength. It was really, people a lot of times I think are very skeptical of 3D printed threads and their strength. The first prototype I made for this, I screwed in the bolt and all of the print, and I was probably not the best idea. I was using an impact driver and I over tightened it and the print around the threads collapsed.
Oh,
and
wow.
my engineering brain was like, that was so interesting. Yes, this 6-hour print just failed, but like, let's take a look at this and see what happened. And it was really interesting to like see the failure pattern and notice how I could improve the strength, which ended up being increasing the number of perimeters and the top and bottom thickness. Cause it kind of, that was the limiting factor in my, and not over tightening it again.
Of course.
Cause it is plastic at the end of the day versus metal, and metal will win most times.
Yeah.
And I, instead of buying 30 washers, just 3D printed washers, because all they had to be were spacers. I'm trying to think of any other modifications I made. Oh yeah, and like he makes a very simple handle in his, and I thought, well, this could be a cool opportunity to add like a fun design element. And I love those old vintage flywheels that have the curved spokes on them. So I thought it would be fun to make like a red flywheel on mine and kind of make it look like a submarine hatch, or like the Valve logo, this like turn me, just screaming at the person looking at that this thing should be turned.
Nice.
So it was a really satisfying project because it took days to print. It's a lot of volume, even printing with like 20% infill. Yep. And it worked well at the end. Now I will say, like, a lesson I learned here was that this thing is better in wood. The fact that it's made of plastic, it is inherently shakier. Like without a doubt. So for a camera jig, which is something you want to be stable, I think wood does make a lot more sense, especially for all these long pieces that connect the plates together. Like as I've been able to explore more fabrication techniques, I'm starting to realize like where 3D printing might be advantageous and maybe it's not worth doing. For something that's linear and has 2 holes in the end, in my opinion, like there's not much reason to 3D print that if you don't have to. Now for a more complicated shape that has a bunch of holes and maybe takes a little more like motor skills to drill out and maybe machinery that you don't have, something like that. I think just the plates on this, if I 3D printed them and then replaced those long parts with wood, it would work fantastically.
Yeah.
So it was a very interesting lesson in like where 3D printing has its advantages and where it falls short.
Well, and there's also the whole area of materials that could be explored there. It seems to me that, PETG definitely has some positive attributes when it comes to strength, but it does have a little bit of flex to it as well. And I'm thinking maybe trying something more rigid like a polycarbonate would be worth exploring too, because it seems like that would work as well as a wood if you found the right material. That's one of the things that's nice about 3D printing is it's not just about finding the right shape or building the right geometry, but then you've got hundreds of different materials that you could explore to give it different sorts of properties and characteristics.
Yeah, I'm really excited to explore more materials. Like at this point, it's really only PLA. I'm excited to hear you say PETG. That means that in my videos, I don't have to say PETG, which is very difficult to say in a
most people know
well-articulated
PETG
way.
these days. Yes.
Okay, I'm gonna start saying PETG and TPU. But like things like nylon, how strong it is, I really want to experiment with that.
Absolutely. Yeah, nylon has great strength properties, but it also has that's another one that has a little bit of flex to it. So for something like this, I don't know that it would be a good choice for the actual frame components. Like I said, the most rigid one that comes to mind would be something like a polycarbonate, which your machine can probably still handle. That would be my guess.
Cool.
You'd have to look at the specs, but I suspect you'd be able to work with that. All right, so let's talk about a couple of others here. And the next videos I wanted to ask you about have to do with sort of bringing together leatherworking with 3D printing. And you mentioned this before, that you had been doing leatherworking before even getting into 3D printing, but then once you got the 3D printer, you found a way of bringing those two together. So let's talk about some of those projects you've done of 3D printing tools and lettering that can be used for then embossing or stamping on leather. And tell us about how you got the idea and how you went through that process.
Yeah, I'm not sure if I can remember how I got the idea originally. Like many ideas, it seems like 1 second you don't have it and 1 second you do. And, when people get leather items, a lot of them want customization. They want their name on it. They want a poem on the cover of a book cover, maybe a custom pattern or something. And when I started doing some commissioned leather work and I realized that I could add this for people, it was really exciting. All of a sudden I could be like, okay, like tell me whatever you want on it, I'll be able to do. So a lot of it just started with names and things, but then as I started exploring other things, I eventually got to the point where I basically 3D printed an entire plate to emboss the cover of a journal. So I kind of designed this Art Deco pattern in Fusion and then embossed that onto a book cover. And that at the time for me was like really pushing the limits of what you can do with this technique, because if you take vegetable tan leather and you soak it in water, it becomes this plastic material and can accept impressions. And people have been doing this for hundreds, if not thousands of years. And there's very traditional ways of stamping it and carving it, which I had done some of in the past. But what I love doing is embossing it. So taking that stamp and just clamping it in place, because you get a really crisp impression and you're not worrying that if the stamp bounces when you hammer strike, it's going to double strike or something. But very small stamps, you only have to clamp for around a minute or so because it's so much pressure and the leather just compresses really, really quickly. But for something like that book cover, which was something like 6 by 9 inches, and it was embossed, so most of the area was actually being pushed under the surface and a very small amount was being left above. I left that in clamps for, I think, 40 minutes. I probably should have left it clamped in overnight if I really wanted like a really strong impression that would especially show up after the leather has dried. Like when that happens, it doesn't become quite as dramatic. So yeah, it was this really great thing that I could integrate into my leather work. I did some kind of like little gnome stamps for a friend that wanted a belt with some gnomes on it. Like I mentioned, the poem embossed onto a cover. I mean, I don't know if you know of like the Open Press project, but the whole like 3D printed letterpresses and all that, like people are doing amazing stuff with that. And it's cool and it's fun. I used to work at this kind of STEM summer camp, and I went back as a guest speaker, and the activity that I came up with the kids was 3D printing modular alphabet stamp sets, which you can buy made of metal. But based on my experience with these stamps, I'm like, I can definitely make this with 3D printing. So with the camp, because we had to run this for like 40 kids, we just 3D printed 20 sets of these stamps, and a lot cheaper than buying them all in metal if you are a camp like they are with 30 3D printers. So they could kind of just batch those out in no time. And then you can also do whatever font you want. So then if you're using that technique where you have the letters that you can switch out, all of a sudden you have like infinite flexibility. So yeah, it's a really fun way just to add like whatever customization that people want.
Yeah, that's great. I've never seen that approach using 3D printing in combination with the leather working in quite that way, but it makes perfect sense when you show it and explain it. I just never seen it done that way. So another video that I wanted to touch on, that it gets into the idea of when you're making something and using 3D printing, you don't always have to have every aspect of the object 3D printed. It might involve 3D printing something and then embedding or attaching metal components or hardware, other things like that. One of the examples of where you might want to do that is if you need something that has magnetic properties. And so you did this video showing a 3D printed magnetic quick release mount for a bike light, where you needed to have some metal in there in order to help it to attach. So tell us about that and what the experience was in designing around that for something that you would 3D print and sort of leave a space that something would be inserted later, and how that project was done.
Yeah, so that was a really fun one because kind of as a gag gift, a friend had bought me this Triceratops headlamp because he knew that I liked to camp. So it's this ridiculous toy. And I was just thinking, like, I kind of wanted to do something with this. And I live in the city and I bike all the time. So I was like, well, I should turn this into a bike light. I'll have the most unique bike light in the city. So I wanted a way to take it off of my bike very quickly so that I can change the batteries and it won't get stolen. So I basically designed like this 2-part quick release mount. One part just sort of zip ties to the frame, and the other part has magnets in it that attaches to this Triceratops. So there was a lot of design that had to happen there for a sort of a fun project. So the first thing was that you had these complex curves around these triceratops, and just matching those was took a lot of like mental gymnastics and looking at it in multiple directions, and finally realizing that like there was actually only one direction of curvature, but I could take a reference photo from the other direction and sort of just trace that out. A lot of making that curve, extruding it, subtracting out the outline. And it was a multi-part print, which I'm a big fan of, because especially for larger items, you know, if you can split it up into multiple things where the success or failure of one doesn't impact the success or the failure of the others, then it's not this huge sunk cost if you have any problems in your print. So in this example, like matching that curvature to the Triceratops light had no impact on the part that actually attached to the bike. So I tried to split it up in a way that made it as easy to make as possible. And then the most fun part, which was this magnetic quick release, was essentially I had these big neodymium magnets, not too huge, probably like an inch in diameter and 1/8 of an inch thick. And on their own, those probably wouldn't hold the light on, because something I've learned in other projects with magnets is that magnets are really weak in shear. You know, the way that you separate magnets is like try to slide them against each other. So if you were to knock that light, yeah, the magnets might be super strong if you try to pull it directly away, but if you try to slide it, it'll come right off. So a really easy way to solve for that is just adding some pins. And if you are 3D modeling it and you only want it to go in one way, then you just make a random pattern of pins. It's actually in a funny scenario where, like, you know, as humans, we love uniformity. But if you want something to just go in one way, then you kind of have to go out of your way to make them like super random so that it just clicks in only one orientation. So I just added a few pins, printed it, and left a space for the magnet. So again, in my 3D printing journey, I've tried to get those exact fits. And a lot of times it bites you in the butt, because if you're off by a hair, it just won't work. And especially when you're trying to glue something in place, I'm like, I'm not even going to try to get an exact fit. I'm going to leave plenty of room for epoxy. And I don't want this thing sticking out above the surface, because neodymium magnets are a little fragile. So if they hit each other, they can shatter. So I made more than enough space so that it was sunken under the surface, and I can even cover the top in epoxy, and then just held it in place with some 5-minute epoxy. And because I left enough clearance for the pins and the magnets, everything clicked together great, and it's super strong. I've biked around it a lot with the city, and it's really quick to just take off. So it's cool, like, because you might see one of these magnets and think, well, it can't really support that much weight. But if you start adding some like little interface pins and things, and you orient it in the right direction, then they can make for some really great mounts.
Yeah, excellent. Okay, so I'm going to go to one more sort of category of your videos that I wanted to talk about, where you get into using reference photos for designing parts in Fusion. And I wanted to talk about this because I think for me, this was one of the most powerful aspects of designing that I had learned, that brings a whole new dimension to your ability to make parts, especially when you're trying to maybe replace something from the real world, maybe a piece that you have that's broken and you want to reproduce it. So tell us about that. There's 2 videos in particular, one about how to use reference photos to design functional parts in Fusion, and another one where you use that method to design 3D printed tool holders. So let's just talk about that in general. How do you tell us about what that is, of how you use reference photos in Fusion? What does that mean? What are the benefits of working with reference photos?
Yeah, so there's this great feature in Fusion called inserting a canvas. And that canvas can be anything. It can be any JPEG that you want. But a great way to use it is by using reference photos. So if you have, let's say, a pair of pliers that you want to build a holder for, you can take that pair of pliers, lay it on the table next to a ruler, or a lot easier is to lay it on a cutting mat that has marked divisions, and take a picture of it from as directly overhead as you can, so that you get a perpendicular shot with as little perspective error. And you take that photo and you insert it into Fusion. And if you scale it to the proper size, then you can just trace the parts you need and make your design based on that. The alternative to that would be taking a bunch of measurements from your part, trying to remember in your head what each measurement is, and then connecting all the dots in a sketch in a series of other commands.
Yeah.
So especially for something like 3D printing, which compared to like metal CNC does have a little bit of inaccuracies, you know, if you take a good reference photo and scale it properly, it will be like surprisingly accurate. But especially for things that don't need to be like dead on, it's a great solution for getting something that interacts with the real world very, very well.
Great way
So
to get close easily.
get really close and closer in your model than probably your 3D printer can even notice the difference of.
And
um,
and
yeah,
let's point out also that when you're dealing with three-dimensional objects, you can capture images from each direction. So you can take a picture from the front, from the top, from the side, and you can lay those onto each of those appropriate planes in Fusion, right? So you can
yeah.
actually get sort of a three-dimensional reference that you can build around. It's a very powerful technique. So I was glad to see you show how to do that in your videos.
Yeah, and I think something worth mentioning is when I actually get those reference photos, what I'll a lot of times end up using is the spline tool. So just drawing very freeform curves that, you know, is just made up by a series of points, but the computer knows how to form it into a nice solid curve, and then you can take those control points and move them around to get it like a really, really nice fit. So reference photos plus splines are, you can do anything with those.
Nice, nice. Okay, so like I said, there's way too much content on your channel to go through all of it. I do encourage people to go and check out the YouTube channel and your Instagram page and others. We're going to talk about those links near the end. But I do want to ask about one other thing before we have to wrap up here, which is, I believe it was just this last weekend that you did an event where you offered free 3D printed repairs at a place that you were up in Toronto. And you invited people basically to come in and bring their household items, whatever they may have that needs to be fixed or mended, and you would work with them on the spot to come up with something in 3D printed. I've never seen anyone try to do something like that live and in real time. How did that go for you?
It was fun. Learned a lot, and I definitely want to do it again based on those lessons that I learned. So this was directly inspired by Van Neistat, who's a maker and a filmmaker and a creator. He made this video where he did a very similar thing in a flea market in California, and his was a traditional method repair station. So he set it up in the back of his Land Cruiser at a flea market, and people came with their broken cameras or whatever, and they had him fix it there. And because he's an artist as well, a lot of it was just putting his artistic touch into people's personal possessions. You know, they just wanted a little taste of Van Neistat in their Swiss Army knife or their camera or whatever else. And I mean, fantastic premise for a video. And being in Toronto, I want to start and continue integrating the city more into my videos and interacting with people and going out on the street and just having all those interactions, which just make things more fun and entertaining and fulfilling. So I thought, like, he did that, like, that was an awesome video. What if I set up a table in the street somewhere and did like free 3D printed repairs for strangers? That would be so much fun. Would make a great video. It'd help people. It's a win-win-win. And, you know, it seemed a little like chaotic to do it outside in the street. And I eventually realized that I could do it maybe in a storefront. And there's this makerspace cafe very close to where I live called the Maker Bean. And I thought about approaching them and asking about it. And thankfully, the owner is awesome and he was really into the idea. So we set up a date 5 days after I asked him. And it was really fun. I advertised it on local Facebook groups. And I had 5 repairs over the course of the day. I was hoping for a little more, but I think with not too much notice, I would call it a success. And had some great conversations. A lot of people who had never seen 3D printing before. Because it's funny, we always talk about how it's becoming so prolific and common, 3D printers, and they've become so cheap. But there's still a lot of people who have never seen one, don't even know how they work. And I think because we put it on these Facebook groups, it attracted a lot of people in who just kind of wanted to see what it is. So I had a lot of, you know, I had these 5 repairs, but then I had a bunch of other people who just kind of wanted to check it out and see what was going on.
Sure.
And it made me sort of realize the target audience, I think, a bit better, which is a lot of people are very attached to like a certain item that they technically could replace. And it might be cheaper to replace it, but they really love that original item and they don't want to buy a new one. They want to fix the thing that they have. They may be like eco-conscious or just love that item in particular. So I sort of like realized that was a lot of the emotion that I was drawing off of. And I think I made some people like really happy because this item that they love and they thought like they would just have to live with the issue. So in one case, a fan that had lasted for 30 years, the adjustment knob had crumbled. So she brought me in the fan of the one that was still existing, and I basically recreated it and tried to improve it a little bit. So on the original one, it had the 0, 1, 2, 3 power settings just painted on. And I was said, well, I'm going to emboss those into the surface. So I just did a little press pull into the surface, and now it's better than the original, in my opinion.
That's terrific.
So it was really fun. I definitely am going to give more notice beforehand because I was hoping that because it was on a busy street, we would get a lot of people coming in just by walking by and seeing the sign. But if you go to a repair store, you know, you have to have something in mind that you want repaired. So definitely a little more advanced notice will make the next one more busy. But hopefully, I mean, I'm not sure exactly when this video is coming out, but I'm guessing that video will be out by the time that this podcast comes out.
Terrific. Yeah, it's a great idea. I certainly hope you are able to do more of those because it's a great way to help people to understand what you can do with this technology. It's just, I think so many people, like you said, don't quite get the 3D printing yet. They still see it as something sort of magical, and when they start to understand that it is accessible, that you can use it to solve everyday problems, that's pretty exciting.
Mm-hmm.
Well, so a lot of great stuff for people to look at. If people want to see more of your work and support your work, let's share some of the websites. I know you've got a website and blog at morleykert.com. We're going to put all these links down in the description, by the way. Your YouTube channel, definitely check that out. You can search for Morley Kert on YouTube and you'll find the channel there. On Instagram at Morley Kert. And I want to point out that there's a Patreon page too, and that link will be down below as well. And among the options that are there, I noticed there's a $5 a month subscription option, which among other things gives you 50% off any of the digital designs that you want to purchase from Morley. That seems like a steal to me, so I just wanted to call attention to that. It seems like a really great program. And then you also have some merchandise, and there'll be a link to that down below as well. And I wanted to include that one because I really like your merchandise design. You have a design that shows 3D printing equals freedom. And I just think that's great. It's the kind of thing, like you said in one of your videos, actually, that I think people would actually want to wear and help kind of get others aware and excited about 3D printing. So I just might have to pick one of those up myself.
Thank you.
So we'll include all those links below. I hope people will check that out. Morley, I want to thank you for joining me today. This has been a fascinating conversation. I wish we had more time. There's so much fun stuff that you're doing.
Yeah, thank you so much. It was really interesting, and I feel like I've really scratched the surface of 3D printing. Like I do a lot of my own designs, but there's so much more that I want to explore. I want to try out resin printing. Like we said, all these other materials. I never even really thought about polycarbonate. I got some research to do tonight.
Yeah,
so thank you for having me on and giving me a bunch of things to think about.
Absolutely. And we'll definitely stay in touch. I want to follow up with you and have you back in the future so we can learn about all the fun stuff you've been up to and how your 3D printing has progressed. But thanks for all your time today. This was a really great conversation. And thanks to everyone for watching and listening. We'll see you next time.